In this video, I'm just going to show two pieces or two clips of film showing the Wilkinson rolling forge. It's a rolling blade forge that uses a round or half circular die in order to extrude a sword or machete blade or bayonet blade. Now in the video, the first video will show some recent footage from a machine pictured supposedly in the WKC factory in Solingen. The other older videos from the late 1950s from Wilkinson Sword showing one of their machines working, drawing out sword blades. So the two machines operate quite the same way. They are based off the original machine that the founder of the Wilkinson Sword factory actually patented back in, I believe, 1845. I have to check that. But the machine was patented by Wilkinson in the United Kingdom, and was then used extensively in machete, sword, and bayonet production throughout Europe, and I believe also the United States. I'll get back to that in a moment. So Wilkinson patented in the machine, and then in the 1880s, I think, WKC received the license to distribute and probably manufacture the machine in Germany or within their markets. The machines were probably manufactured by both Wilkinson and WKC, as far as I am aware. There is a patent in regards to the United States. There is a patent from 1874 or 1875 from Remington that shows a rolling forge patented, pretty much just a blatant copy of the Wilkinson device. I can only presume either Remington realized that Wilkinson had not patented it in the United States, patented, and then sort of tried to block Wilkinson from collecting their royalties, or there was something else at play, where they were, trying to get exclusivity of the Wilkinson machine in the United States or in the Americas or something. But it's just a lazy copy of the Wilkinson that had been already around for 30 plus years. So, I'm pretty sure that Remington used those machines to forge their yataghan bayonets and other sort of firearms bayonets. And I don't know whether Collins had such machines or not, but based on their machete production, early Collins machetes show to be forged by hand, but later machetes are definitely done in a rolling die. So, and I'd imagine those rolling dies from Collins, when they shut down, probably went to Mexico, and then into the ether at some point after that. Because Collins did have some manufacturing in Mexico, and those machetes are also extruded on a rolling die as well. So that's probably where all the Collins equipment and possibly equipment from Remington and other makers in the US as well. The European machines, again, probably museums, scrap heaps. It's quite a very specific looking machine. So if somebody sees that as an auction with old tools or something like that, they probably can't see a use for it generally, for sort of average light industry or something like that. So the chances are a lot of those ended up in scrap heaps. In South America, in Coma and Imacasa, they both companies that have their origins with WKC in Solingen, and there was also a manufacturer in Brazil, Corneta. All three of those South American makers still use, Corneta in Brazil is gone, but there's two surviving manufacturers in South and Central America used the logo Cornetta, which was owned by VKC in the past. They use a rolling forge, and also Martindale from England uses a rolling forge. I believe their rolling forges are now all possibly in their factory in Thailand and maybe in Ghana as well. So I don't know if they have rolling forges in the UK anymore. I don't know the age of their forges, but they look pretty old as well. Although one in the Wilkinson video really looks like a machine from the 1840s. The one in the VKC video looks like something manufactured within the last 75 years. So it is, considering the methods in which swords and machetes were produced prior to 1845, being forged entirely by hand and then ground on a stone to take to bring the surface to a smooth sort of pattern and so forth. The amount of labour that went into producing a blade, especially a deeply fullered blade or a very thin tapered, a blade with a sharp taper to it, was actually quite substantial. They had power hammers, going back far into the late medieval period. They had water hammers and so forth, and they had water hammers with shaped dies in their jaw, in the head of the hammer. So people could use a crude sort of, much cruder method of forming certain contours and certain shapes that would be more difficult to form by hand, like a fullering die or something they could use. But it wasn't really until the Wilkinson rolling forge appeared that you had, about that same time, you had sophisticated power hammers. So when you've got the option between a sophisticated power hammer with an easily changeable die, or you have a machine that will extrude that blade in one hit, one or two rolls, well, the Wilkinson machine looks substantially better on a number of factors. There's a device called a rider hammer, which was patented around the same time as the Wilkinson rolling forge, and the rider hammer was used in conjunction with the Wilkinson rolling forge. So they would buy the strips of steel already cut to a certain shape. Prior to that, they would buy the steel forged from the mills, in the early 19th and 18th century, forged into almost like a propeller type shape, narrower in the middle and then wider on either end, and they cut it into two pieces and forged two swords from that. Because they're still forging it by hand. But with the advent of the rolling forge and the rider hammer, they would buy it in a strip or a bar, and then they would put it through the rider hammer. Each rider hammer looks like a power hammer, but it's set up with 4 or 6 hammers that will strike in conjunction, like the cylinders of a vehicle. So you can go from one hammer to the next to perform a step. For example, you can hammer in a fuller in one step, and in the next step you can dish that fuller out, etc., etc. So they would use the dies and the rider hammers to forge the blades into certain strip dimensions in order to feed them into the rolling forge. I'm sure they probably could have bought that directly from the manufacturer, those strips, but it would more likely save them a lot of money, a lot of time. They wouldn't have to buy this massive bulk of certain sizes of steel in order to feed them into the rolling forge. With these machines were used for both sword production and machete production from 1845 onwards by a number of manufacturers. And so machetes, for example, prior to that time would have to be hammered out by hand, ground smooth. It was quite a lot of work. But with the rolling forge, they could, with 2 steps, they could produce a machete with a taper from tang to tip and from spine to edge that needed just surface finishing and having a bevel put on the edge and the handle applied. So they could produce, thousands of machete blades within a week with just a couple of workers, probably dropping the price of machetes substantially. and I would presume around that time it really had a drastic effect on local machete production in the Americas, at least, because you just couldn't have compete. You may have been able to compete on price, but not on quality. You know, the structural integrity of a thin blade that's extruded out as opposed to a blade that's hammered out on an anvil. It's just no comparison between the two. The grain structure of the steel and the nature in which it's forged just produces a much better blade. You need a good quality blade, very good tempering and hardening, and a very good steel for machete blade. In actual fact, it doesn't have to be very high carbon, but it needs to have sufficient carbon. It needs to be hardened very well, and it's thin. It's under a lot of force, so it does actually need to be well made, or it's next to useless. Unlike a thicker bladed tool or knife or something where its defects won't become as apparent as easily. With the manufacturing of the blades with the rolling forge, you could say that sword making reached its pinnacle of quality, and that at this point now in the 21st century, because those machines have been discarded in exchange for CNC machine blades and so forth, you can say that there is an inferiority of technology. The rolling forge is superior. It is impressing an exact image of what you want into a strip of steel while that steel is heated to a certain temperature, and drawing the grain and the structure of that steel into the shape you want, as opposed to machining it. Rolling forges are still used in some high stress components in automotive and aviation industry and so forth, in order to maximize the grain strength and maximize the shear resistance of the steel product and so forth. But generally, they've fallen by the wayside for swords and so forth, just because people are no longer fighting each other with sword blades. So the chances that people will give some feedback or negative feedback to a sword manufacturer are pretty limited by comparison to 130 years ago or so. With the rolling forges, it seems like as the industry of machete and sword production has declined, and things have been made in Asia more and more, mostly in China, I should say, machetes more and more that are just stamped from low carbon steel, heat treated and so forth, but they're just a flat stamped piece of steel. The amount of manufacturers of machetes has really, of proper machetes, has really shrunk. So you've got Martindale, and you've got two South American manufacturers. There used to be one in the Dominican Republic as well that was using a rolling forge, but they've long gone. So you've got three manufacturers left in the world that are using rolling forges to manufacture blades for machetes, and then you have maybe one company in Solingen that owns the machines, but it's highly doubtful that if he is using the rolling forge, it's more likely that they've got those forges in India in a business that they own in India or China. So they really are a sort of an extinct piece of technology, almost, I shouldn't say extinct, but endangered piece of technology that is actually quite old and also incredibly ingenious when you compare what was being used before, a hammer, maybe a power hammer and a fullerene die, and what came after. It's going from a racehorse to a race car. Basically, you could view that sort of technological jump and superiority. When you look at a sword with a blade that's been done with a rolling die, it's very dimensionally consistent. The only real inconsistency you could experience is if there's been some excessive grinding or finishing. So if you take two blades that are forged with rolling forge and you look down them from tang to tip, you'll see a very smooth, almost glass-like smooth surface. If you look at a blade that's been forged or done in a power hammer with a die or one of those rider dies or something, you'll see that there's always an unevenness. Even a CNC machined blade will have some unevenness because you can't do certain contours and curves that have to be ground in, that the rolling die can finish before the person needs to do their work on them. CNC blades can have very accurate dimensions, but there's certain steps that generally will be ground in by hand that will be inconsistent from one blade to the next. Which it's a less complete process and a more time-consuming and substantially more expensive process than using a rolling forge. But because modern swords are made in such small quantities by comparison, and people aren't as concerned, I imagine, with those characteristics as what maybe people were in the 1840s. People see CNC as more palatable. Making a rolling forge would be a fair bit cheaper to make than a CNC machine, but making the rolling forge dies will cost you, a couple of $1,000 for a set of dies, when with a CNC mill, you still need a jig to hold that blade, but because you have the CNC mill, you make the jig yourself. And then you hold the blade in the jig, and once you've got that, you can make one sword at a time. So unfortunately, most of those rolling forges probably ended up being scrapped, or maybe ended up in some museum or something like that, because it does look quite an archaic machine, even though even today it's quite an efficient machine for making cutting tools. Anyway, there's two bits of footage showing how they work, and just a bit of information, history on the rolling forge and its ingenious characteristics.